In this video, I'd like to talk about writing the negation of a quantified statement. So what I mean by a quantified statement is a statement, a logical statement that contains a quantifier. And I've given some examples of quantifiers here, words like all, every, each, none, no, some, at least. This is many of the quantifiers, but it's not a complete list. So there's two types of quantifiers. There's universal quantifiers, which tell you exactly how many objects are being referenced. For example, if you have, let's say, a group of, 4 objects, the word all means exactly 4. Every means exactly 4. Each, 4. None or no means exactly 0. But if you have some objects out of 4, well, that could be 1 or 2 or 3 or 4, and same thing with at least. Now, one of the things that makes this concept of writing the negation of a statement somewhat confusing is that some of these words have different meanings mathematically than they do conversationally. So, for example, let's say you're eating. Let's say you have a bag of grapes that you're eating, and I walk up to you and I ask you a question. Can I have some grapes? Can I have some grapes? And you very nicely say, sure, you could have some. And I take the whole bag and walk away. Now, does that seem like I did what I asked? I asked for some and I took the whole bag. Well, no. Conversationally, the word some means only part of something, not the whole thing. But mathematically, I didn't do anything wrong because the word some has a different meaning mathematically. Some means anything other than nothing, which can include part of a thing or the whole thing. And so when we think about an object or a group of objects, there's these three we could call them three quantification states. There's nothing, there's everything, and then there's part but not all. Part but not all. Okay, so we have these three quantification states. Now down here I have four logical statements. Call them P, Q, R, and S. And we want to give the negation of each one of those. And each one of these contains a quantifier. All crabs live in the ocean. At least one of my classes is boring. Not every flower smells good, and no birds could fly. And so, to write the negation is sort of like the opposite. To write the negation of a statement, we have to negate the quantifier. Now, the problem is, we have a statement and its negation. So there's two statements there. The statement and the negation. So what we want is not P. What is the statement not P? And what is the statement not Q? And then we'll do not R, not S. So we have to negate the original statement, but the statement and its negation have to account for all three of these quantification states. So if I said write the negation of the statement all crabs live in the ocean, well, intuitively, it might make sense to say, well, negation, opposite. Well, the opposite of all is none, so no crabs live in the ocean. All right, that would be wrong. That would be incorrect, because in that case, the statement P deals with nothing. The statement P deals with everything, all crabs live in the ocean. But to say no crabs live in the ocean, that as being the negation, well, that only accounts for the nothing state, which doesn't include, so that's the part, but not all is left out. So that we can't do. So let's erase this. Now, one way that I like to think about this idea of negating these quantified statements is to look at, let's say, a small group of objects. Let's say there are only 3 crabs that live in the world. Only 3 crabs. So 0, 1, 2, or 3. So if I say all crabs live in the ocean, well, that means 3 crabs live in the ocean. But the negation has to account for all the other cases. The negation just can't be the 0 case. The negation has to account for 0 crabs, 1 crab, or 2 crabs living in the ocean. Okay, so what quantifying word accounts for the 0, the 1, or the 2? Well, we could say not all crabs live in the ocean. Now, there's not, just like in English, conversationally, there's many ways to say the same thing. Same thing here. There's multiple ways to give the negation here. So, not all crabs live in the ocean. That would be the first one that comes to my mind. So, in the case of there being 3 crabs, not all means anything other than 3 live in the ocean. All right. So let's look at the second one. At least one of my classes is boring. Well, again, I like thinking about a specific number. So let's say you're taking 4 classes. How many are 3 classes? How many could be boring? Well, 0 or 1 or 2 or 3 could be boring. So at least one of my classes is boring means 1 or more. So at least one being boring. Ooh, let's make that. I'm going to go back to using red and green. So at least 1 means 1 or 2 or 3. So that would be what the statement is referencing, which means the negation has to reference only the case of 0 classes being boring. So for the negation, we could say none of my classes are boring. None of my classes are boring. Okay? So this is not something you have to do. This is not a method that's presented in the textbook, but I like thinking about, a specific number. It might be helpful to just write the 0, 1, 2, 3 and circle the cases that refer to the statement. And then whatever's left over have to be referenced by the negation of that statement. Not every flower smells good. Well, let's say there's only 3 flowers in the world. So not every means everything other than every. So anything other than, in this case, anything other than 3. So not every or not all. If there's only 3 flowers in the world, all would be all 3. All would be 3. So the statement deals with or refers to the case of 0 or 1 or 2. So the negation would be all 3. So not R would be every flower smells good. Or you could say all flowers smell good. Each flower smells good. It's something that means everything. And then finally, no birds can fly. So we want the negation of S, the negation of no birds could fly. Again, let's say there's only 3 birds in the world. How many could fly? Well, no birds can fly mean exactly 0 could fly. So that's our statement. Our statement is referring to only the 0 case, which means the negation has to account for all the other cases. So again, intuitively, if you say, what's the opposite of no birds could fly? Well, that would be, you may say all birds could fly, but that's not true. That's not the negation. The negation has to account for the part but not everything, as well as the everything. So the negation would be some birds can fly. Or you could say, just like with R, I said you could also say all. Instead of all flowers smell good. Another way of saying the negation of S, some birds can fly. Some is the same as at least one. At least one bird can fly. All right, so that does it. Those were the 4 problems that I wanted to do. Let me just scroll back up to the top. This idea of nothing, everything, and then the middle, the part but not all. It's important if your statement covers that, your negation has to cover that. Okay. I think that's a pretty good way of thinking about these problems. All right. So that's it for this video. I hope this was helpful.